Okay, we're introducing a new topic today, which is iteration. This is the first lesson of what will either be a 2 or possibly 3 lesson topic. Iteration stands alone as a skill, but it has links with solving equations and therefore is under algebra. Okay, now I'm going to take some time to explain to you what iteration is and what an iterative formula is. Iterative formula, so that you've got an idea of how it works. And there is some notation that I'm going to have to explain to you in this video to help make sense of that before we look at questions. So here is a sequence. The numbers in the sequence are generated using a rule. Here is another sequence. Both of these sequences and the third one use the same rule. Now you can all tell me what that rule is, I hope. That rule is that the next term is 2 bigger than the previous. So you'd say that would be plus 2 each time. This sequence and this sequence use a different rule, which is that they are minus 3 each time. So, okay, let's look at some more. These are sequences that go up and down by the same amount every time. This is another example of a sequence, and one that hopefully you've seen before. So this sequence is the Fibonacci sequence, where you add the previous 2 terms together to get the next number. So 1 and 1 makes 2, 1 and 2 makes 3, 2 and 3 makes 5. Now, a sequence like these can be described in many ways, and there is a formula, an iterative formula you can come up with for generating the next number, which links to this rule here. Let me try and write that down for you now. If you're adding 2 each time, you could describe that using notation. You could write this down. Can you see how this relates to adding 2 each time? Well, don't worry if you can't, I'm going to explain it to you now. Okay, U represents a term in the sequence. So U1 would be the first term, U2 would be the second, U3 would be the third, and so on. So this one here is the 4th term. Here we have UN plus 1 and UN. Now, if we have a term, first term, second term, third term onwards, UN would represent any term in that sequence. So any term in that sequence. So what would UN plus 1 represent? Well, if a sequence went U1, U2, U3, and then somewhere along the line was UN, what would the next term be? Think about this number. It's increasing by 1 each time. So if this one is UN, the next one would be UN plus 1. So what that means is that if U subscript n is your general term, then UN plus 1 is just the next term. So this is any term, the general term. and this simply corresponds to the next term. So let's try and read this now and see if you got it right. U to the n is any term. If you add 2 to that, you get the next term. Or, reading it the other way around, to find the next term, you need to take the general term and add 2 more. Now, I think it's easier to read it this side gives you this. So let's do a couple more to check. So if I said to you, un take away 1 equals un plus 1, what does that mean for the sequence? Well, that means any term, when you take away 1, gives you the next term. There's a term. The next term will be 1 lower. So it would give me this sequence. Let's try again. Any term in the sequence plus 3 gives me the next term. So if the sequence starts with 10, the next number would be 13, then 16, then 19 and onwards. Let's try another one. What does this one mean? Well, this one means you take any term in the sequence and you double it to find the next term. So this would be a sequence like this, where if you say this term, double it to get the next one. To help you see these, I'm going to now put numbers in here and just check. So this sequence, this un plus 1 equals 2un, I could read it as, imagine you were doing the specific case rather than the general term. If I put the first term in here, and I said that. Remember what we said? That these correspond to terms. So the first term doubled makes the second term. It also means the second term doubled makes the third term. And the third term doubled makes the fourth term, and so on. So an iterative formula is one where you generate the next numbers in a sequence using this notation. So here's another one. I'll put a 5 here and a 3 here. So if you take a number in the sequence, times it by 5, then take away 3, the answer is the next term. So if the first number was 1, times it by 5, take away 3, gives you the next term. Take this one, times it by 5, take away 3, times it by 5, take away 3, and so on. Now, you might think it was easier just to say add 2 on each time, rather than to try and write it in a complex notation. But this is just a notation we need to get our heads around before we look at actually using iteration to solve anything. So what you need to do now is look at video part 2, where we'll start to use an iterative formula like this to generate numbers in a sequence.